Hi friends, in this lecture, we are going to talk about Java Enums. We are going to talk about the Enum basics, the Enum internals, and also some of the best practices that we as developers can use in our projects. Stick to the very end because towards the end, we are going to talk about the internals of Enum and go deep into what classes it creates. And this would be very helpful in how we actually think when it comes to Enums. So let's start with the basics. One of the most important things to model in Java are the reference types. These are the types which have a fixed set of possible items. For example, when you think about days of a week, there's only 7 days in a week, or 12 months in a year. And these are called as reference types. Typically, when we model reference types, we do something like this. This is what we used to do during our early days in Java, where we used to have public static final constants in an interface. For example, if you look at a timer unit, there are, let's say, 4 possible values hour, minute, second, and millisecond. We would create one public static final integer for each one of those types. And whenever we want to use it, we would pass that as a parameter. For example, we are going to pass that as a parameter in the handle time method. And you can see the second parameter, which is the unit, and that's what we would do. However, this is a bad solution for two main reasons. One is that it is not expressive enough. That means just by looking at the method, we don't know what needs to be passed to unit. And secondly, it is not type safe. The compiler cannot easily figure out whether you have passed a wrong information for unit, because the developer can easily pass 1000 or -1 to unit, and the compiler will happily accept it. So it is not type safe. So because of these reasons, Java had come up with the Java Enums. So the same thing can now be modeled using an enum as follows. This is basically the explanation of on why we should not be using the public static final ints or strings to model reference type. But if you look at the enums, an enum can be defined as follows. You just use the keyword enum and then the enum name, in this case timer unit, and you have a bunch of constants in there, hour, minute, second, and millisecond, each representing a reference type. So just so you know, the timer unit enum, when it gets compiled, it compiles to a timer unit.class. So internally, it is still a class. Java is giving you a higher level abstraction to this class for reference type. And each one of those constants, hour, minute, second, and millisecond, is actually a timer unit object under the hoods. And we will come to that very soon. And when we use the enum in this fashion, and this time when we pass it to the handle time method, the second parameter now is timer unit. And this time the compiler knows exactly what needs to be passed. And if you do not pass a timer unit, the compiler is going to scream. So only a possible set of values can be passed to the second parameter, and that is why it is type safe. Also, it is much more expressive because a developer who looks at this method knows exactly what needs to be passed as the unit. So now that we have defined a Java enum, let's use it. If I want to access the R, I can just simply say timerunit.r and assign that to a timer unit. We can pass that to any other method. Now, behind the scenes, one thing I forgot to mention is that there's only one copy of the object per constant. And that means this is like a generalization of the singleton pattern. In singleton pattern, only one object exists per JVM. In enums, there's a number of objects, one representing each constant that exists in the JVM. So let's go ahead and look at some of the methods that can be used in the timer unit or an enum. So first method is the name. The name method in an enum actually returns the string representation of the constant. So if r is a constant, it will represent a string called r. And that's what this will print out, a string r, H-O-U-R. There's another method called value of, which is a static method on timer unit that gets generated. And if you pass the string representation of the constant, it will return you the object representation of that constant that is the timer unit. So in this case, timer unit.value of R will return the timer unit for R. And because we also mentioned that there's only a single instance of the constant, later on, if you go ahead and compare it with timer unit.R, you can just simply use equal to because the reference is going to be the same. We don't have to use equals method. And this is definitely a performance boost. So in that particular statement, that assertion will be true. There is also a method called values. That's going to be returning an array of timer unit objects, one per constant. So it's a good way of iterating over all of the reference values for a particular reference type. So in this case, I'm just iterating over these constants and just printing out the timer unit as well as the ordinal value for that reference constant. And what is an ordinal value? Ordinal value is an internal integer value that is associated with each constant. As a developer, you should not even be using ordinal because ordinals are not reliable. When we change the order of the constants within the enum, the ordinals will change. So don't ever take that ordinal and save it in a database or something like that. If you want to use it for an extremely trivial thing and not something important. Now, one important thing that we can use in enums is in switch statements and switch expressions. And this is very important because when used within the switch expression or statement context, it helps in checking the completeness of the switch. For example, if you look at the switch expression out here in the slide, this is going to give a compile error because we have a missing case. Millisecond is not represented in the switch, and that's why it's not even going to compile. Now, why is this useful? This is because tomorrow, if you add a new case nanosecond to this, what that means is that the compiler is going to scream at you to tell you that you have to change this switch as well. And this is a good thing because it will not lead to runtime error. And of course, this means that we are not using the default case out here. If we use the default case out here, that compiler error is not going to occur. And that is why when we use switch statements with enum, don't use the default. It's a good practice not to use the default case because that way, if you add a new enum constant, you're going to immediately get a compile error if you miss something. As usual, any problems at compile time is much, much better than the same problem happening at runtime. Now let's do something else. Up till now, you might be wondering how this timer unit is actually represented within the JVM. We talked a little bit about it. We said the enum compiles to a class. But what kind of class does it generate and what does it look like? And that's what you see on the screen. If you run the Java P command on the timer unit.class, the result that you see is on the screen. You can see the final class called timer unit getting created and which extends from a class called enum. And you can see 4 constants out there. The hour, minute, second, and millisecond all got converted into a public static final timer unit objects. And also what got generated were 2 static methods, values and value of, both of which we discussed earlier. And there's also a static block. What is not seen is that the hour, minute, second, and millisecond gets initialized as part of the static block. Because what you see on the screen is just a structure of the class using the Java P. A lot more of it can be seen if you give Java P minus V, that is the verbose option. All of the bytecodes can be seen, and how all of these constants get initialized in the static block can also be seen. But this gives you a good idea how to imagine the timer unit enum now, because finally it is nothing but a class with a bunch of public static final objects. So let's print the class name. So if you extract the R constant from the timer unit and go ahead and say instance of timer unit, this is obviously going to return true because we know that the unit is of type timer unit. And when you say unit.getClass, it's going to print timer unit. Now this also seems pretty obvious, but it is not. In this particular case, it will definitely print timer unit. But we will see other cases where it might not print timer unit, but it might print a different class, and we will come to that soon. So now let's talk about some properties, because up till now we have been talking about enums where there's just a bunch of constants. But let's say we want to associate each one of the constant with some, say, code and description. So in our case, the timer unit needs to be associated with code and a description. So what we will do is that we'll create a constructor, because we know that timer unit is nothing but a class. We will create a constructor with two parameters, code and description, and then define private final string as both code and description. But once you define that, you also need to go and change the constants, because remember, the constants are nothing but objects themselves. So we have to provide concrete data to that. So our minute, second, and millisecond will have its own code and description. And of course, we have the accessor methods that is needed to access it. Now that we have defined a timer unit with properties, let's see how to access it. So here's a unit, which is timerunit.r. If you want to extract the code and description, you can say unit.getCode. You got the code, and you say unit.description, unit.getDescription, you will get the description. So that's pretty straightforward. But apart from enum properties, we can also put methods in there. You can add a toString method in your timer unit enum. Remember, the default toString method just simply returns constant name in a string format. But if you want to change that and include the properties as well, you can do that. That's not shown here, but you can do that. And that can be accessed from any of those constants, hour, minute, second, and millisecond. But an interesting example is that you can also put abstract methods in there. So for example, in this case, I want to add an abstract method called snooze. And the time that is being passed to snooze can be a long, and its unit is determined by on which object that the snooze method is being called. So we consider this abstract at the timer unit enum level, but more importantly, when you look at the constants, hour, minute, second, and millisecond, you can override that abstract method snooze to have its own implementations. And this is a very interesting example, because now you have 4 different snooze implementations where the unit of the time is different, because the time which is passed to hour is in hours. And so it has to be translated to milliseconds when you actually call thread.sleep. And same thing with minute, second, and millisecond. So how do we use the snooze method now? We can call timerunit.second.snooze5, and that means it's going to just wait for 5 seconds. It's going to sleep for 5 seconds. If we use timerunit.millisecond.snooze2000, it's going to wait for 2000 milliseconds, which is basically 2 seconds. And so the implementation of the snooze is different based on which object it is being called. So now in this particular scenario, what kind of classes are getting created or generated when we compile this enum code? Because this enum code is a lot more complicated than before, because it has an abstract method snooze. So if I run the java p command on timerunit.class, you will see some interesting things. This class timer unit is no longer final, it's now abstract, because we have an abstract snooze down here. Everything else remains the same. But there is an interesting thing. Because this is abstract, the compiler also creates 4 implementations or 4 subclasses of timer unit class. And it will associate those subclasses with each one of those constants. And those subclasses are timer unit $1, timer unit $2, timer unit $3, and so on. So if I go and do a java p of timer unit $1.class, this is what you see on the screen. You have a class called timer unit $1, timer unit $1, which extends from timer unit. So it is extending from the timer unit class and providing an implementation of its own. So you have 4 such implementations of classes which are final and which extends from timer unit, and having implementations of the snooze. And this was necessary to be done in this way because we really had 4 implementations out here of the same method snooze. So remember, we have to think about hour, minute, second, and millisecond as objects, and that is why we provided the snooze at the constant level. Java is providing us a shortcut way of creating an object here. So with this information in place, if I now go and get the class or print the class for hour and second, it's now going to be different. It's not going to be timer unit. It's going to be timer unit $1 and timer unit $3. So don't get surprised when you see class names which are different than the enum name that you gave. Because a lot of times the Java compiler can create a subclass of the enum class and use that. So I hope you enjoyed this small talk, which gave you some knowledge about the internals of the enum. And now when you look at enums, you can also think about the class it creates. And if you have any confusion, you can see the class and see how it gets created. And with this, you can imagine the enum. So hopefully this has given you a good overview of the basics of enum, about the internals of enums, and also how best to use it in your projects. If you like this video, give a big thumbs up, and also do not forget to subscribe to my channel because I do provide original content in this channel.